Today we're going to talk about how to solve linear systems by elimination. Before we do that, let's do a quick review about common multiples. What would be a common multiple with opposite sign for 2 and negative 5? (10 and negative 10). How about negative 3 and 6? Negative 6 and 6. And what about 6 and 9? (18 and negative 18). I'm sure you're wondering how this applies to solving linear systems. When we're using the elimination method, we use opposite coefficients from the same variable to eliminate it in the linear system. Remember, our goal is to get a solution from the linear system. If there's a solution point, the solution is written as a what? That's right, an ordered pair, and it contains the x and y values where the lines intersect. So we can solve linear systems algebraically using substitution and elimination of linear equations. The equations must have all like terms lined up in columns. Using the standard form of a line is really helpful to do this. What's the standard form of a line again? I hope you said ax plus by equals c. Remember to get opposite coefficients. And the big one, look for multiples. If multiples aren't obvious, make it happen. They're there. Okay, let's look at example 1. First things first, are the equations lined up by like terms in columns? No, they are not. So we have to put the equations in standard form. The second one is in standard form. So we just need to put this first one in standard form. And we can do that quite easily by adding y to both sides. That gives us x plus y equals 5. So then we need to make them stacked up with the like terms in columns. You should notice that we have a single y, one y, but in the first equation it's positive, and in the second equation it's negative. So if we added these two equations together, the y's would cancel each other out. So what I did here was I added x and 3x to get 4x. I added 1y minus y to get 0, and 5 and 7 to get 12. From here, we can solve by dividing both sides by 4. And dividing 12 by 4, we find that x equals 3. From here, it's just like solving by substitution. We substitute the x back into one of the two equations, and it doesn't matter which one. In our case, the first one is going to be easier. So I plugged 3 in for x in our first equation to get 3 plus y equals 5. And then by subtracting 3 from both sides, we find that y equals 2. Don't forget, Write your solution as an ordered pair. All right, let's look at example 2. So first things first, are our equations lined up with like terms in columns? No, they're sure not. So how do we do that? We put the equations in standard form. By rearranging the second equation, we can get them into standard form. So we have 2x plus 2y equals 6, and 3x minus y equals 5. We don't have opposite signs on either of the variables, but could we make them? We have positive 2y and negative y. So if we multiplied our second equation through by 2, we should be able to eliminate y. So we get 6x minus 2y equals 10. So now, when we add our two equations together, our y's will cancel out. 2x plus 6x is 8x. 2y minus 2y is 0. 6 plus 10 is 16. Now solve for x. X equals 2. Now we plug 2 back in for x in one of our equations. In this case, it really doesn't make a difference which one. I picked the second equation, so I plugged 2 in for x and got 3 times 2 equals 6, which equals 5 plus y, so y equals 1. Don't forget to write your solution as an ordered pair. Ask the guest teacher to pause the video at this point if you guys need to take a minute to look at the solution more closely. Otherwise, it's time to move on to a story problem. All right, so let's read our problem and look for important information. Caesar and Brutus are selling apple pies and lemon meringue pies for a school fundraiser. Caesar sold 6 apple pies and 4 lemon meringue pies for a total of $80. Brutus sold 6 apple pies and 5 lemon meringue pies for a total of $94. What is the cost of each of 1 apple pie and 1 lemon meringue pie? Let's start by defining our variables. Let's call A apple and L lemon. So we need to create the linear system. So let's start with Caesar. Caesar sold 6 apple pies and 4 lemon pies for a total of $80. Brutus sold 6 apple pies and five lemon pies for a total of $94. So our equations lined up by like terms and columns? Yes, they are. Because I wrote them in standard form. So what variable should we eliminate? In our system, both equations have a coefficient of 6 on A. So if we multiply one equation through by -1, the A's will fall out when we add the two equations together. So -6A plus 6A equals 0. And -4L plus 5L is 1L. And -80 plus 94 is 14. So L equals 14. Then we plug that back into one of our equations. I chose the first one. So I plugged in 14 for L. Take a minute and go ahead and solve for A. So A equals 4. So in the context of this problem, lemon pies cost $14 and apple pies cost $4. Now it's time for some whiteboard practice.